You think you understand how your phone works. You don't. Every time you touch that screen, every time you send a text, every time that camera focuses, you're witnessing something that should be impossible. Something that violates every rule of electricity you ever learned. Pull out your phone right now, look at it. That little rectangle contains billions of components that work by breaking the laws of physics, not bending them, breaking them. And the weird part, engineers designed it that way on purpose. Right now, as you hold that device, 15 billion tiny switches are turning on and off. Each switch is smaller than a virus. Each one controls the flow of electricity by doing something your physics textbook said was impossible, making electrons disappear on one side of a wall and reappear on the other side. No tunnel, no hole. They just pass through solid matter like ghosts. Most people think electricity is simple. You flip a switch, current flows, lights turn on, easy. You learned in school that electrons move through wires like water through pipes. When there's a gap in the pipe, the water stops. When there's a gap in the wire, the current stops. Makes perfect sense. You probably think of your phone's processor like a tiny city with roads. Electrons drive down copper highways, turn at silicon intersections, stop at red lights, go at green lights. All very organized, all very mechanical, all very wrong. Let me show you how wrong. Take a single transistor in your phone, just one of those 15 billion switches. It's about 7 nanometers wide. That's roughly 20 atoms across. Imagine shrinking yourself down until you could walk across those 20 atoms like stepping stones across a creek. Now imagine someone told you that sometimes, instead of stepping from stone to stone, you could just disappear at stone number 10 and reappear at stone number 15. No bridge, no tunnel, no teleporter. You just vanish here and materialize there. You'd think they were describing magic. But that's exactly what electrons do in your phone. Millions of times per second in every single component. Your phone has gaps everywhere. Tiny gaps measured in atoms, but gaps nonetheless. According to everything you know about electricity, your phone should be a paperweight. The current should stop cold at those gaps. Your phone should be dead, silent, useless. But here you are, probably reading this on that impossible device right now. So what's the trick? How does current cross gaps? It can't cross. Most people say semiconductors, like that's an answer. That's not an answer. That's a label. You didn't explain it. You renamed it. Others might say, well, the electrons jump across. Jump? Jump how? Electrons aren't fleas. They don't have little legs. They don't build up speed and leap. And even if they could jump, they'd need enough energy to clear the barrier. In most cases, they don't have nearly enough. Here's what really bothers me about the standard explanations. They make it sound normal. They use words like flow and current and switching as if electrons were just tiny balls rolling through tiny tubes. But if that were true, your phone wouldn't work at all. Let me show you what I mean. Take the simplest part of your phone, a single transistor. Your phone has about 15 billion of them. Each one is a switch that can turn on and off billions of times per second. And every single one works by doing something that your high school physics teacher would call impossible. That teacher would tell you that electricity needs a complete circuit. Break the circuit, stop the current. But inside each transistor, the circuit is broken. There are barriers that electrons shouldn't be able to cross. Yet somehow they do, constantly, predictably. This is where most explanations cheat. They'll talk about doping silicon, or energy bands, or depletion zones. Technical words that sound impressive but don't actually explain the mystery. They're just more sophisticated ways of avoiding the real question. How does an electron get from here to there when there's a wall in between? Let's build this from the ground up. Forget your phone for a moment. Let's talk about walls. You're sitting in a room. There's a wall between you and the next room. Can you walk through that wall? Of course not. Walls are solid. They stop things. That's what makes them walls. Now imagine I tell you that sometimes, maybe one time in a trillion, you could just walk straight through that wall, not break it down, not tunnel under it. Just pass through it like it wasn't there. You'd think I was crazy, but that's exactly what electrons do in your phone. They walk through walls constantly, billions of times per second. Watch what happens when we stop guessing and start measuring. In the 1920s, physicists discovered something impossible. They fired electrons at barriers, thin walls of material that should stop them cold, and some of the electrons went right through, not around, through, like ghosts walking through a wall. They called it quantum tunneling. And before you ask, no, that's not an explanation either. That's just a name for something we can measure, but can't explain in familiar terms. Here's what actually happens. Step by impossible step. An electron approaches a barrier. In the classical world, the world of common sense, the electron should bounce off. It doesn't have enough energy to climb over. It can't dig under. It should stop. But electrons live in the quantum world, and the quantum world has different rules. In the quantum world, an electron isn't a little ball. It's a wave, and waves do something very strange. They leak. Imagine you're shouting at a wall. Most of your voice bounces back, but some of it, just a tiny bit, passes through. Someone on the other side might hear a whisper. The wall didn't disappear. It didn't break. The sound just leaked through. Electrons do the same thing. When an electron wave hits a barrier, most of it reflects back, but some of it, a small amount, leaks through to the other side. The electron doesn't climb over the barrier. It doesn't smash through. It tunnels through the quantum uncertainty of the barrier itself. This is the part your brain wants to reject. In our everyday world, objects have definite positions. A ball is either here or there, not both. But electrons exist in probability clouds. Before you measure them, they're partly here, partly there, partly everywhere they could be, including on the other side of barriers they shouldn't be able to cross. The math is brutal, but beautiful. The probability of tunneling drops exponentially with barrier width. Make the barrier twice as wide, and the tunneling rate drops by something like a factor of 1,000. Make it 3 times as wide, and it drops by 1,000,000. But here's the key, and this is where your phone comes in. Make the barrier thin enough, just a few atoms wide, and tunneling becomes common, predictable, useful. If that's true, then every smartphone is a quantum machine, and that changes everything. Engineers figured this out in the 1960s and 1970s. They realized they could build useful devices by controlling quantum tunneling, not by preventing it, by harnessing it. Imagine being able to control how thick those probability walls are. Make them thicker, and fewer electrons tunnel through. Your switch is off. Make them thinner, and more electrons tunnel through. Your switch is on. Control the thickness precisely, and you can control the current flow precisely. That's exactly what happens in a field effect transistor. You apply a voltage to a gate that sits next to the channel where you want current to flow. The voltage changes the effective thickness of the quantum barrier. More voltage, thinner barrier, more tunneling, more current. Less voltage, thicker barrier, less tunneling, less current. It's like having a dimmer switch, but instead of controlling the brightness of a bulb, you're controlling the probability that electrons will teleport across quantum barriers. Flash memory, the kind that stores your photos, your apps, your text messages, works by trapping electrons on the wrong side of barriers they tunneled through. When you save a photo, your phone forces electrons to tunnel through barriers onto tiny islands of silicon where they get trapped. Electrons trapped, 1 point. No electrons, 0. Binary code written in quantum mechanics. Every selfie in your phone gallery exists because electrons tunneled through barriers they shouldn't have been able to cross. Now we hit the real question. Why does quantum tunneling happen at all? Why do electrons behave like waves that can leak through solid matter? At some point, you hit bedrock. The universe operates by quantum mechanical rules, not because it makes sense, not because it's satisfying, because that's what we measure. That's what experiments show, over and over and over again. The why question, the one asking for a familiar explanation, doesn't have an answer. Quantum mechanics doesn't reduce to something more comfortable. It's not like springs or rubber balls or flowing water. It's the fundamental operating system of reality. And that operating system includes tunneling. But here's what we can predict. If you know the energy of an electron and the height and width of a barrier, quantum mechanics gives you the exact probability that the electron will tunnel through, not approximately, exactly, to dozens of decimal places. And that precision, that mathematical bedrock, is what makes your phone possible. Let me show you how tunneling actually works in the device you're holding. Your phone's processor is made of silicon. Pure silicon is an insulator. Minus electrons can't move through it freely. But engineers don't use pure silicon. They poison it. They add tiny amounts of other atoms, phosphorus, boron, that change everything. When you add phosphorus to silicon, you get extra electrons. When you add boron, you get holes where electrons should be. Put phosphorus-doped silicon next to boron-doped silicon, and you create a barrier between them, a barrier that electrons want to cross but can't, at least not classically. This barrier, this junction between different types of silicon, is the heart of every electronic component in your phone, and it works entirely because of quantum tunneling. Think of it like this. Imagine you have two swimming pools at different water levels. There's a dam between them. In the classical world, water can't flow from one pool to the other unless you open a gate or the water level gets high enough to flow over the dam. But if water molecules were quantum mechanical, some of them would tunnel through the dam even when the water level was too low. The thinner the dam, the more water would tunnel through. When you apply a voltage across the junction, you're tilting the energy landscape. You're making it easier for electrons to tunnel from one side to the other. Control the voltage precisely, and you can control the tunneling rate. Turn tunneling on, current flows. Turn it off, current stops. That's a transistor, not a mechanical switch, not a valve, a quantum tunnel that you can open and close with voltage. Your phone has 15 billion of these quantum tunnels, each one switching on and off billions of times per second, each one working because electrons can do something that billiard balls can't, pass through solid barriers by existing as probability waves instead of definite particles. Let me give you some numbers that will blow your mind. In a modern smartphone processor, each transistor switches in about 50 picoseconds. That's 50 trillionths of a second. In that time, light travels about 15 millimeters, roughly half an inch. During each switching event, millions of electrons tunnel through barriers. Each barrier is about 1 nanometer thick on about 5 atoms. The electrons don't climb over these barriers. They don't smash through them. They quantum mechanically tunnel through them. And this happens 20 billion times per second, per transistor, in 15 billion transistors. That's 300,000 quantum tunneling events every second. 300 quintillion quantum mechanical impossibilities every second in the device you're probably holding right now. But it gets even weirder. Your phone doesn't just use tunneling for processing. It uses quantum mechanics for everything. The touchscreen works by measuring tiny changes in electrical fields when your finger approaches. The camera uses quantum effects in semiconductors to convert photons into electrons. The battery stores energy by moving lithium ions through barriers they tunnel through. Even the speakers use quantum mechanics. The permanent magnets work because electron spins align quantum mechanically. But quantum tunneling isn't just in your phone. It's everywhere around you. The LED lights in your room work because electrons tunnel across energy gaps in semiconductors to produce specific colors of light. Solar panels convert sunlight to electricity through quantum tunneling effects. Even the fusion reactions in the sun, the process that keeps us alive, happen because protons tunnel through the electromagnetic barrier that should keep them apart. Medical scanners, car sensors, digital cameras, wireless chargers, they all depend on quantum tunneling. We've built an entire technological civilization on something that classical physics says is impossible. This is where it gets really unsettling. Quantum impossibility isn't exotic science fiction. It's your ordinary Tuesday. Reality doesn't care what feels reasonable. This quantum behavior isn't a theory anymore. It's not speculation. It's engineering. We design our most sophisticated technology around quantum tunneling because it works, because it's predictable, because the math matches the measurements. Here's what really gets me. We understand quantum tunneling well enough to engineer it, but we still can't explain why it happens in terms that satisfy our intuition. We can calculate exactly how many electrons will tunnel through a barrier of a given thickness and height. We can predict the current flow to incredible precision, but we can't tell you why reality works this way. And you know what? That's okay. Physics isn't about satisfying our need for comfortable explanations. Physics is about finding patterns that let us predict and control nature. And quantum mechanics gives us both prediction and control with unprecedented precision. The universe doesn't care what you find satisfying. It operates by quantum mechanical rules, whether you understand them or not, whether you like them or not, whether they make intuitive sense or not. But here's the beautiful thing. Once you accept that reality is quantum mechanical at its core, everything else starts to make sense. Not intuitive sense, mathematical sense, predictive sense. Your phone works because reality is fundamentally probabilistic, not mechanical. Because electrons are waves, not particles. Because barriers can be tunneled through, not just climbed over or smashed through. Wait, here's the weird part. Every component in your phone was designed by engineers who understand quantum mechanics better than they understand their own kitchen appliances. Think about that. The quantum physics in your phone is more precisely understood, more carefully controlled, and more predictably engineered than almost anything else in your daily life. When you design a bridge, you have to account for wind, weather, earthquakes, metal fatigue. There are uncertainties everywhere. But when you design a quantum tunnel in a transistor, the math is exact. You know exactly how many electrons will tunnel through under specific conditions. Quantum mechanics isn't the mysterious, fuzzy, uncertain theory people imagine. It's the most precise theory in all of physics, the most successful theory ever created, and it's built into every component of your phone. Now you're probably wondering, if tunneling is so fundamental, why don't we notice it in everyday life? Why don't you tunnel through walls? The answer is size. And this is where your intuition completely breaks down. Tunneling probability depends on mass. The heavier an object, the less likely it is to tunnel. An electron has almost no mass. A person weighs about 1028 times more than an electron. Run the numbers. The probability that you could tunnel through a wall is so small that you'd have to wait longer than the age of the universe. Not just this universe, trillions of universe. But for electrons, in barriers just a few nanometers wide, tunneling happens constantly. It's not rare, it's routine. This is what I mean when I say your intuition evolved at human scale. Your brain learned to predict the behavior of objects you can see and touch. But electrons live in a different world, a quantum world where the rules are completely different. Your phone works by exploiting those different rules. Here's the weird part. It works anyway. Your phone doesn't care that quantum mechanics makes no sense to you. Every time you take a photo, quantum tunneling is controlling the sensors that capture light. Every time you connect to Wi-Fi, tunneling is switching the radio circuits on and off. Every time your phone remembers something, tunneling is writing data to flash memory. Let me walk you through what happens. When you take a selfie, light hits the camera sensor. Each photodiode converts photons into electrons through quantum effects. That electron tunnels through barriers to create a tiny current. The processor reads those currents using billions of quantum switches and converts them into digital numbers. Those numbers get stored in flash memory by forcing electrons to tunnel through barriers onto tiny islands. When you look at the photo later, more quantum switches read that data and display it on the screen using more quantum effects. From photon to pixel to memory to display, every step involves quantum tunneling. Your selfie exists because reality is quantum mechanical. You're not just using quantum mechanics, you're commanding it. You're telling billions of electrons where to tunnel and when. And they obey, following the mathematical rules with perfect precision. Think about what this means. The most familiar technology in your life works by principles that completely violate common sense. Principles discovered less than a century ago. The universe doesn't just allow impossible things, it builds useful, practical technology out of them. We understand these quantum effects well enough to mass produce them. Your phone isn't a laboratory experiment. It's one of billions of identical devices, each containing identical quantum components that work identically. If the model can predict it, we're getting warmer. And the quantum model doesn't just predict tunneling. It predicts exactly how much tunneling, when, where, and why, with precision so extraordinary that we can engineer devices that depend on tunneling working exactly as calculated. This is where your intuition breaks. The most advanced technology you own works by breaking the rules you learned in physics class. Your phone exists in the quantum realm. It operates by quantum rules, and somehow it presents you with a classical interface that makes perfect sense to your classical intuition. It's like having a car that runs on magic, but has a normal steering wheel. The interface is familiar, but the engine operates by completely alien principles. That's the weird part. It works anyway. Quantum mechanics doesn't need your permission or understanding. It just works reliably, predictably, practically. So the next time someone tells you quantum mechanics is weird, abstract, impossible to understand, show them your phone. Tell them it works because electrons can walk through walls. Tell them the processor in their pocket runs on pure quantum impossibility. You don't need to understand wave functions or probability amplitudes to use quantum mechanics. You just did. Every tap, every swipe, every calculation your phone just performed happened because reality operates by quantum rules, not classical ones. Engineers figured out how to make electrons tunnel through barriers before physicists fully understood why tunneling was possible. They built working devices based on equations they could solve, but couldn't fully explain. That's the beauty of physics. You don't need to understand why the universe works the way it does to harness how it works. You need good measurements, good math, and good engineering. Think about the audacity of it. In the 1920s, physicists discovered that reality was quantum mechanical. By the 1940s, engineers were building quantum devices. By the 2000s, everyone carried quantum machines in their pockets. Less than a century from discovery to ubiquity. From that's impossible to where's my charger? Your phone represents one of the greatest triumphs in human technology. Not because it's convenient, but because it proves we can harness the fundamental forces of nature even when they violate our deepest intuitions. Every component was designed by people who accepted that reality is probabilistic at its core, not mechanical. They took the most counterintuitive theory in science and turned it into the most practical technology in your daily life. The universe is not built for your comfort. It's not built for your intuition. It's built on mathematical principles that often seem impossible. But those principles work. They're predictable, they're precise, and once you know how to use them, they're incredibly powerful. Understanding isn't comfort, it's power. And right now, you're holding more quantum mechanical power in your hand than existed in all the laboratories of the 1920s combined. The impossible made practical. The weird made useful. That's not magic, that's physics. The universe was quantum mechanical all along. We just had to learn to listen to what it was telling us. Your phone is proof that when we stop demanding that nature makes sense to us and start learning to make sense of nature, there's no limit to what becomes possible. Welcome to the quantum world. You've been living here all along.